Hi, I'd like to start by thanking the organizers of the workshop and of the MultiON challenge, and I'm happy to present our work learning mapping and spatial reasoning with auxiliary tasks. Joint work with Laetitia Matignon, Olivier Simonin and Christian Wolff. In MultiON, an agent is tasked with reaching a sequence of target objects placed in a photorealistic environment. As a result, being able to build a representation of such environment and using it to navigate efficiently are important abilities. Now, from the work introducing MultiON, I'd like to present 4 baselines that share the same base architecture where we extract context information from a global map. Now, the difference between baselines is in the nature of the map. First, we have 2 oracles that have access to privileged information. For Oracle map, it's the full occupancy map and object locations. Oracle Eagle map only knows about object locations within regions it has already explored in the episode. No map is a recurrent baseline, and procedural map builds its own map by projecting extracted features using depth information. In this work, we build on top of those baselines, and in particular procedural map, by adding auxiliary tasks that help the emergence of mapping capabilities to the base PPO training that rewards agents when reaching efficiently new target goals. Indeed, while looking for those target objects, we'd like our agent to be able to answer those 3 questions. First, have I seen this object already? And if the answer is yes, what's the direction towards the target? And what's the Euclidean distance between my current location and the target? To do so, we propose 3 auxiliary problems. The first one is a binary classification problem, where the agent must predict if it has already seen the target object in the past. If that's the case, we try to predict the direction towards the goal as another classification problem with angles discretized into bins. Finally, distance prediction is another classification problem where the agent tries to predict the distance between its current location and the target object within an Oracle egocentric map. We augment the base architecture with 3 additional classification heads, one for each of the 3 auxiliary problems. Now let's move on to the experiments. As in the MultiON paper, we evaluate the following agents after 40 million training steps, showing that our auxiliary tasks help to improve significantly the performance of procedural map, matching the performance of Oracle Eagle map. In the context of the challenge, we also tried to see if more training steps were beneficial, and it's indeed the case for our model and the 2 oracles. Our entry to the challenge is this model that is further fine-tuned for 20 million training steps without auxiliary supervision. Next, we augment Oracle Eagle map with our auxiliary tasks and notice a gain in performance. As it already has access to a perfect representation of the environment, this might suggest our losses can help to learn spatial reasoning. Finally, we show that a recurrent baseline augmented with our auxiliary tasks performs much better. The gain is thus not limited to agents that explicitly build a map of their environment. I'd like to thank you for your attention, and I'm happy to answer any question you might have by email. Thanks.